let's find the average efficiency formula. Yeah. All right. Okay, yeah. Here, we use the weighted average. This time we modify our, early versions of average. We will choose appropriate weights when we consider all the cases. The weights could be different. The weights not always the same. Yeah. So in our current question, the weights could be different. Yeah. So we consider the weighted average, and we use two-step calculation. Yeah, because we have matching case and a no match case. So two-step. For matching case, what is the average? For no match case, what is the average? Then we apply weighted average on these two cases to get a final average. Okay, so let's do the calculation in this way. Yeah. Subcase averages first and overall average second. Okay, yeah. All right, the first, yeah. So we can treat the first subcase, matching case. How about the matching subcase? Right? Yeah. So we can find a valid index I for which k equals A of I. That subcase. Yeah. So the average for this subcase is easy, right? Straightforward. Yeah. Because each one, we in our first assumption, each of the n cases occur with the same probability, 1 over n probability. Okay, 1 over n. That's our assumption, first assumption. Yeah. So with this assumption, the average for this subcase, the matching subcase, so that is 1 plus 2 plus n over n. After simplification, 1/2 times n plus 1. But that's for the matching subcase. This average number is for the matching subcase. All right? No match subcase, only one subcase, right? Only one to be considered. So that means its average also 1. Yeah. So that's easy, only 1. Okay? Yeah. But now, our last step, we need to consider an average between these two numbers. Another round of average between these two numbers. But we need to figure out their corresponding weights. The weights could be different. Okay, the weights could be different. So we use P to represent their weights. Yeah. All right. Yeah, for the first subcase, we know the probability is P. That means the weight for the first subcase is P. Similarly, the weight for the second subcase is 1 minus P. Then let's do the weighted average this time. We have all the data we need, so we can calculate the weighted average. So let's write the formula. We combine two subcase averages based on their probabilities in this way. Okay, yeah. So the weighted average equals the first average number 1/2 times n plus 1, then multiply its corresponding weight P. That's the first term. The second term, the average number n, multiply its corresponding weight number, that is 1 minus P. its corresponding probability. Then adding together these two terms, so we get our final version of average, weighted average. That's what we need to find for this problem. After we get this formula, that means we solve this whole problem. Okay? Yeah. And from this simple problem, yeah, so you can see the main concept we learn from this question, average case efficiency. That's the main concept. Okay? Not just the concept, we also learn how to calculate average case efficiency. Here, using the weighted average to do the calculation. Okay? Yeah. Later, when we have many other questions, we also need to calculate the average case efficiency. Basically, we use this idea. Okay? Yeah. Yeah. The structure could be different, but the underlying understanding is the same from, comparing with this example, the same. Okay, yeah. All right, yeah, so we finish part C. Yeah. Any question? Yeah. All right, yeah. If no question, let me move to part D. Another important question for algorithms. Yeah. Oh, yeah. Yeah, here dominant. Yeah, actually, regarding the dominant term, this is related to module 2. In module 2, we will look at the, concept, dominant term and other things. Yeah, here, yeah. So, we do not need to pay too much attention here. Yeah. Here, just because, yeah, later, this is the exact version of the formula. But when we use the formula, sometimes we may not use exact version. Sometimes we may use approximate version. Approximate version. Okay, so this we use. This is the dominant term. This dominant term is a good approximate version. Okay, yeah. So we ignore some minor terms. So you can see to use this approximate version, how much we ignored. Okay, the ignored part. Yeah. So the part with M, we keep it. So this part, actually look at the ignored term equals 1/2 P. This term is ignored. Okay, yeah. But we know P is between 0 and 1. P is a probability, right? Yeah. So this number is less than 1/2. So if you ignore this term, we only get a possible error less than or equal to 1/2. That's not much. This small difference, we can take it. Okay, we can take it. So people, most of the time, so this small difference is not significant. Yeah, yeah, but we keep this, dominant term. Yeah, this dominant term we will elaborate in our module 2. Yeah, all right.